Okay, so welcome and nice to be here. My name is Anatoly and I'm a Kafka trainer and author of this book here. And I would like to talk to you today about Kroxylicious. How many of you would say they are Kafkateers doing something with Kafka? Okay, how many of you are interested in the Kafka world and the streaming world? Good. One more question. How many of you are running Kafka in production? Yeah, some of you. Okay, cool. So, Kroxylicious. It's about a Kafka proxy, or I would like to focus the talk on how to cope with garbage in, garbage out, one of the core principles of computer science. But let's start first about what makes Kafka great and awesome. And in my opinion, it's the log. What is the log? Yeah, the log is one of the easiest data structures. You can put messages in using, for example, in the Kafka world, we call them producers. Put messages in, 1, 2, and we have a consumer, and the consumer reads the messages from the beginning to the end. We can have multiple producers, and the producers can all produce messages into the log. And yeah, they produce messages. And in Kafka, we split up the log into multiple distinct logs. We call them partitions. And partitions form a Kafka topic. So basically, a topic is like a database. It has a name. And then for performance and for performance reasons, for parallelizability, we have the multiple partitions. And this way, we can have many consumers reading from the topic. So these are the very, very basics of Kafka. And in general, this works very nicely. It works and works and works. We produce more data, more data, more data. But the problem with Kafka, or the advantage with Kafka, and the problem with Kafka is that Kafka doesn't care. So in my trainings, I teach always the two most important concepts of Kafka is Kafka doesn't care and Kafka brokers are lazy. If you know these, you can guess how Kafka works. The problem with not caring is the garbage in, garbage out problem. If you produce data that is garbage into Kafka, your consumers will get garbage out and maybe explode. Let's have a look. Let's just look at one producer, one partition, and one consumer. And the producer produces some data to it, triangle, the consumer is happy. Let's produce another triangle, the producer is still happy. And let's produce even more triangles, and finally another triangle. What happens to the consumer? Kafka doesn't care, it just accepts the message, forwards it to the consumer, and the consumer explodes. What should we do? The problem is that Kafka treats the log and every message as a byte array. So it doesn't interpret the messages, it doesn't look at them, it just doesn't care. We call these messages poison pills, the shitty messages. One way how to solve it is to introduce the schema registry. So instead of just putting the messages into the partitions, we have now the schema registry that is a place where producers and consumers can register schemas, or CI/CD pipelines can register schemas. And when a producer tries to produce a bad message, the producer library will stop it from doing so. So first, how does it work? Producer retrieves the schema, the consumer retrieves the schema, producer produces a message, looks good, it's fine, consumer is happy. Another message, everything is fine too. Another message, looks good. Now, the producer tries to produce a shitty message, but as you're using a serializer here that is talking to the schema registry, the library will tell you, nah, don't do that. This doesn't work. maybe in the way how I phrased it, you might see a problem. Let's imagine, the next messages are fine. Let's imagine we have another producer here. And this producer was developed by the other department, yeah, on the other side of the floor or on the other building. And you know about them. They like to implement bugs. As the schema registry is a client-side check, you still can produce messages as you want. So our consumer crashes. Bad. There are different products that avoid that. So if, for example, if you're with Confluent, then Confluent has a kind of schema validation thingy, but actually just checks the first 5 bytes whether there's a schema in it or not. They do not actually validate the content of the messages. This is not too well known. But we have now a nice crocodile, Kroxylicious. Or if this word is too hard, just call it Proxy. It's the nice crocodile, and it has long teeth, so it can bite you if you do something bad. Kroxylicious is in the end just a Kafka proxy. It is put between the client and the Kafka broker, and what it does is you send requests to it. You can transform requests in Kroxylicious, and then it forwards them. In the other direction, it gets Kafka responses. You can apply transformations to it, or filter that, or do whatever you want, and it's forwarded to the client. The essence is this, yeah. Kroxylicious is a component that allows you to do something with your requests and responses. One way what you could do is you could, for example, look into a request, see, oh, this is a produce request, check whether the content is valid, and then deny the production if you don't like it, or allow it. Or you could rewrite messages, or you can reroute messages, stuff like that. It's up to you. There are a few filters that are already implemented in Kroxylicious, but it's an open source project with a library. You can do in the end whatever you want. So, if we now do record validation with Kroxylicious, we have now our producer. We have now our proxy in between. The Kroxylicious retrieves the schema, and we have the proxy on the other side too. And here, the consumer retrieves the schema because on consumer side there's no validation here. So basically, consumer requests are just forwarded, and producer requests are checked based on a schema, for example. And now, if you have a bug in your producer and try to send the message, Kroxylicious bites it and will say, no, not with me, not today. Try it again. Consumer stays happy. Sounds easy and isn't too hard. I think on the conceptual level, it's quite clear what happens. Let's have a look at the demo. I don't have a video, so no backup for me. I like to live on the edge. That's right. So we are here in my training environment, and I think I should increase the font size a bit. Increase. Okay, so what I did is I started already a Kafka cluster with 3 brokers, and it is already running. And next I download the latest proxy, latest proxy release, which is 0.18. It's quite early days of proxy, even though it's, I think, 2 years old, something like that. But still, it's not very widespread, so be a bit careful with that. Then we configure proxy. So let me increase the terminal. Whoops, what did I do? And so we configure Kafka. We configure Kroxylicious. We say we have a new virtual cluster, so we can have multiple virtual clusters with Kroxylicious. So, for example, you can have one virtual cluster for one department, one cluster for another department. So with one installation, you can even serve multiple clients. First you say, okay, what is the target cluster? What is the actual Kafka broker? And I just say localhost 1992, no security, nothing. And then you can define multiple gateways. So basically for each cluster you can also define multiple gateways, basically proxies, and I say I have my gateway, it should listen on port 9292, and I also say, okay, my node IDs, so my brokers, range from 1 to 3. Because Kroxylicious expects that you start at 0, I start at 3. And I don't define any filters. I save it, and let's start it and hope for the best. It says Kroxylicious started, looks good. Then let me create a Kafka topic. Just the normal Kafka topics command, but look, bootstrap service 9292. So this is Kroxylicious. As you probably know, Kafka topics and all the tools take a while until they start, and we can also produce messages 1, 2, 3. And now we can also start a Kafka consumer also on port 9292 and see whether the data arrives. Again, the consumer needs a bit to start, needs a bit some time to start, and you see the messages. So apparently something worked. Let's try it on another port. Let's try it on localhost 9092. So the original Kafka. Do the messages arrive? Looks good. Okay, let's do something more interesting. Let's have now, I wrote a producer. It's a very simple Java application producing some wind turbine data, and here we have a consumer that is just consuming JSON wind turbine data. So let me build that. Starting Gradle, and then it should start in a few seconds. Compiling. Run producer, looks good. Produce data for wind turbine, turbine 38, and so on. And then I can run also a consumer. And it should consume wind turbine data. We join in group, and then you see here the data arrives. Whenever something is sent here, it arrives here. If we want to have a look at the actual data, we can also start a Kafka console consumer. Look, it's on port 9292. And look, this looks like JSON. Let's produce a poison pill. Let's produce a message that says, I'm not a valid wind turbine data. What will happen?
It would go through since you didn't set any filters, right?
It will go through, yeah. And what will happen to our terminals?
The consumer will crash on a failure to deserialize.
Okay, let's see. Oh. Okay, it was produced. You see here in the consumer, I'm not a valid wind turbine, but it's the console consumer, so it doesn't care. And let's scroll up. Build failed. Yeah, there's somewhere above is the stack trace. It failed. Okay, let's fix that. So I will recreate the topic, so I will just delete the topic to get rid of the messages and create it again. It's probably not the best way to do, but let's do it again. Yeah, now it works. What we do now is we add a new filter. We call it record validation of type record validation, and the only thing we will do here is we check whether it's syntactically correct JSON. You can also define a schema registry, but it would be a bit out of scope here. We allow nulls, but not empty messages. And now it changed a bit. You now need to define the filters first, and then you need to define which filters should be used by default, and you can, in each virtual cluster, you can define the filters that should be used. So let me open the config again. So let me first start here, stop Kroxy, and open VI, and now I'm just adding here the filters. Set past. And you see here, here's the filter definition, the default filters, and that's it. And then I start Kroxylicious again. Here's the crocodile. Let's start the producer again. Let's also start the consumer again. You see the producer is already producing data. The consumer should start too in a few seconds. Rejoining group. You see here the data arrives. Okay, let's produce now a poison pill. Same message as before, same terminal as before, nothing changed. Let's increase the size and let's see what happens. Oh, it failed. Error when sending message topic winter bin data with key null, value 32 bytes with error invalid record exception. Value was invalid, value was not syntactically correct JSON. So basically, Kafka doesn't know this error message. Never heard about it. So Kroxylicious basically, or the Kafka protocol allows you to send text messages back, and this is what Kroxylicious is doing. This is an invalid message. Please try again.
Is that a real error though? Because like Kafka usually wouldn't give that error, right?
So it's what you can do. So basically, it gives back the invalid record exception with the text. So the error messages of Kafka are generic enough such that you could misuse basically the existing error messages for your ideas. Okay? Okay. I didn't show you, but I hope you believe me. The consumer is still running, yeah? I can produce here garbage data. And we'll get the error messages, but our consumers will just continue consuming. Okay. That's one filter I wanted to show. There's another one. What if you don't trust your cloud provider? Sometimes you say, oh, I need to be careful with my data. I don't want to manage Kafka myself. Let me use another company that is managing Kafka, but I don't want them to be able to access my data. How would you do that? Using at-rest encryption, for example, or end-to-end encryption. So you know that, yeah? If you have plain text messages, you send plain text messages over the wire. It is, you as developer are happy. The message is in Kafka. The message gets unencrypted to your consumer. The developer here are also happy. You know who else is happy? That guy. Another approach to that is, or the typical answer to that is, yeah, just use end-to-end encryption. Why don't you just implement end-to-end encryption in the producers and the consumers? But actually, it's quite hard to do that correctly and reliably. And let's not start about key management. So your producers could encrypt the messages somehow magically. How many of you have ever tried to implement it yourself, end-to-end encryption? Is it easy? Straightforward? Yeah. Doing it correctly is hard. The advantage of that is this is the perfect solution. The messages are encrypted in Kafka and then also sent encrypted over the wire. Again, you need to think about about key management, how to decrypt it, how to share keys between different teams, and so on and so on. So the developers are quite unhappy, but the good thing is the bad guy in the middle is also unhappy. Another approach to that is, why do you encrypt it yourself? Maybe you could have a component on your network that encrypts it, sends it to the public cloud. It's stored encrypted. then you download the encrypted data. So by public cloud, I mean a cloud provider and not publicly available endpoints. So let's use Kroxylicious for that. You as a producer send unencrypted messages to Kroxylicious. It encrypts them. You are happy because you don't need to think about that. This is a problem of other people, so of the Kroxylicious developers. Kroxylicious encrypts the data. It is not encrypted. It is sent or consumed, encrypted by Kroxylicious, is then decrypted by Kroxylicious and sent in plaintext to the consumer. The good thing here is, who says that this should be a global piece of infrastructure? You can run also Kroxylicious as a sidecar in your producer. So actually you wouldn't have any network here. You would say, okay, it's over loopback, over localhost. There's no network traffic that goes unencrypted here. And then you might even call it, it's not really, it's kind of end-to-end encrypted if it's really a sidecar. If it's a proxy, I wouldn't call it end-to-end encrypted. But this is the question how you define it. Both of you are happy. The bad guy is still unhappy. Okay. We don't have much time left, so let's see whether the demo works out. So these are our failures. Kroxylicious requires you to use a key management system. It supports AWS, the AWS key management solutions, Azure, Google, and also just Vault. So HashiCorp Vault, I install it here. You shouldn't use development mode for production, and you shouldn't share your root tokens on screen with random people. We enable the transit protocol because this is what is required by Kroxylicious to be used. And then what we do next is we create a new policy in Vault and says KEGs are key encryption keys. So basically these are the keys that are used to encrypt the keys with what the messages are encrypted, such that you can rotate keys much easier. You say, okay, you need the read capability, update capability, and update capability for these keys. And let me create this one. Vim. Now it should work. And then set the policy in Vault. Then we create a new token, the Kroxylicious record encryption token for this policy, and we write it to a file. Okay. And now I would like to create a key, encryption key, a KEG, for my encrypted topic. So basically we can say in Kroxylicious how the which topic should be encrypted. Basically those for which a key existed will be automatically encrypted. And you can also tell Kroxylicious how the key should be named. And I just say KEG underscore topic name, for example. And you see, it will be automatically rotated every 90 days. Okay, it is created. And then we need to adapt our Kroxylicious config, basically adding a new filter, the record encryption filter, and you see here the template, yeah, KEG underscore topic name. So let me stop for Kroxylicious again. Passed. Here you see record encryption. Here you see Vault KMS service as the key management system, then the URL, your encryption token, and then the template. Then I also say my record, I would like to also use record encryption and start Kroxylicious again. And it seems to work. Then I start a topic, or create a topic, my encrypted topic, hello world. Then I start a consumer. The consumer reads my hello world. We are on port 9292, yeah? Let's see what Eve will see. Oh. Kek my encrypted topic, vault, something, and then junk. Seems to work. Okay. These are a few capabilities I wanted to show you about Kroxylicious. Thank you for your attention. To summarize, even though proxies like Kroxylicious exist, be careful. Think about whether you need them, because you add a new single point of failure. If this one fails, you won't be able to communicate with your Kafka clusters. It might be useful to, for example, if you communicate with the outside world, if you want to have partners that should access your data center and you have a DMZ or something like that, if you have network topologies which force you to end your connection, stuff like that, then proxies can be helpful. Also, if you're using very sensitive data in Kafka, then you might use Kroxylicious for that, for end-to-end encryption. But please keep it simple. Think about when to use it, even though please don't do meetup-driven development. Yeah, you have seen it, but it doesn't mean that you need to use it. Then thank you.